Welcome. This is a demonstration of the Requs AI Predict software. It's the only machine learning software reliability prediction tool that predicts software reliability before the code is even written. You can see here I have a project open. We can create any number of projects we want. You'll see there's a bunch of dials. There's actually 19 of them. Each of these dials corresponds to a development factor that has been quantitatively linked to software reliability. So what we're going to do is we're going to go to the Survey tab. You can see there's the sub-tabs there are the same categories we saw on the dials. And there's going to be several questions there to be answered. The goal is not to answer all of them. That's not necessary. However, what we do want to do is answer at least some questions from each of the 19 categories. A lot of people will start from the beginning and answer all the questions in the first 4 or 5 categories, and then they don't answer any in the remaining. And unfortunately, that means the prediction's not very accurate. So again, try to answer some from each category. The required inputs is the basic minimal set of things that are needed to make a prediction. Very important, we have to know things about how many deployment sites. That should be easy to answer. The mission time, the schedule time for the release is also very, very important. This is in years. You can see this one is predicted to have a release time of 12 months, which means every 12 months they have a new feature release. The project size, also very important. You can choose between people years for the project size, which is just in this case 4 people for 12 months. It's the size, or you can enter the case lock. Either one, the software accepts either one. The product information tab, this is actually used by the FMEA functionality. It's not used by the prediction. Same thing for the failure modes tab. It's used by the FMEA software. Now, the prediction software does use the customer satisfaction. There is a direct relationship between how satisfied customers are and reliability. The inherent risks, these are the things that negatively affect reliability for software. The more risk we have, the worse it can be for reliability. So these are generally fairly easy to answer these questions. You'll notice here for most of the questions we have U for unsure, A for always, S for sometimes, N for never. And you'll see we have little tooltips that give you guidance on how to answer the questions. Personnel. The people are very important. This has been known for at least 40 years that having people who understand the industry is actually more important than people who understand the language that the code's written in. So there's a variety of questions there about the background of the people developing the software. We have the planning tab, which is very much related to the software development plan. And these are things that would be found in a software development plan. Execution. This one's commonly overlooked by people when they're thinking about reliability. This is not the execution of the software. This is the execution of the project. This is directly related to how well the people are managing this project. We have software requirements, which you can see. We have questions related to activities. What are people doing with respect to requirements? Fault tolerance. Do we have any requirements for fault tolerance? The content frame basically captures what is in the requirements, what kinds of things are covered, and then we have metrics. That is a familiar pattern we're going to see with design as well, the same pattern, design activities, content, what is in the design, fault tolerance, is it a fault tolerant design, and then metrics about the design. Similarly for code, we're going to see similar things. The criteria is basically things that we'd see in a coding standard. We also have fault-tolerant code, and we have coding statistics. And then unit testing. This is testing done by software engineers. We have similar set of frames here. What are they doing? Are they testing fault tolerance? What kinds of things are they testing? And so forth. And then the testing tab is testing done by people who aren't developers, such as black box testers and that black box testing, system testing, verification, validation. Same thing, we see their activities. What are they doing? What's in the plan? And what's in their procedures? And are they testing fault tolerance? Are they testing the user interface? Are they doing regression testing? Then we have the correction action tab. This is the procedures that they have in place to make sure that when they fix a defect, they're not introducing a new one. Configuration management, this reflects their practices for keeping track of the source code and the versions. And then we have defect tracking. It's been shown that organizations that have a closed loop defect tracking system actually have more defects out in the field. And then we have reliability. These are a collection of things that have been tagged to reliability practices for software. Software QA, software quality assurance. These are things that software quality people might do on the program. And then finally we have process. Process and techniques are two different things. A process means that there's a set of written procedures in place for how people develop software, and that they're followed and that they're repeatable. These are things you might see in the Software Engineering Institute Capability Maturity Model. All right, once we have filled out as many questions as we can, we go to the dashboard. We'll go to the predictions tab. It's now running through the machine learning model. You can see that it gave us our size estimates, lower and upper bounds. It gave us our defect density predictions and our percentile group. The 50 means this project's right in the middle of those in our database. It predicted the defects from the size and the defect density, predicted the failure rate, reliability, and availability. You can also see it gave us a range. This is an actual range from our database, so we can compare our predictions against the range. You'll also see the improved confidence tab. This provides a listing. What this shows us here, and there's a spreadsheet where we can view it easily as well. It shows us the list of questions we did not answer at all, one way or the other. And so, and it gives us the relative impact. So you can see there's a few at the top here. Our relative impact is from 1 to 4, with 4 being the highest. We have a few here where if we answered those questions, it's possible that our confidence in the prediction could go up. Right. Luckily, we answered quite a few questions, so there weren't many on that list. All right, now we'll go to predicted growth in field. This is going to show us not just one point in time number, but it's going to show us the whole trajectory. The predicted operational metrics gives us a tabular view of all the metrics that we have by month. And you can see here, around month 13, the defects are going up. That's because we're having releases every 12 months and we're adding new code. And that is what happens whenever there's a new release. We could see these graphs here. These buttons are basically just graphing each of the metrics. This is a plot of the remaining defects. You can see the very typical sawtooth curve there. That's very typical. It's because over 8 years, we're going to have 8 releases once a year, and each time we have one, the predicted defects is going to reset itself. We can also predict the mean time to failure. We can predict the failure rate. See that? The unreliability and the unavailability. And we can also filter for just the critical defects in these graphs as well. You can also export. And then notice here, I have a line item for the average corrective action hours and average test hours. And so if we hit the recalculate button, it'll show us that the estimated percentage of defects giving this level of effort is really only 57%. So if we add in more hours, let's see what that does. Oh, that made it too big. So somewhere around 700. Somewhere around 700 hours, we'd be able to remove almost 80%. 75% is a reasonable minimal bound for removing defects, so that gives us an idea of about how much test effort we will need. The predicted growth in test tab is very similar to the previous tab, except it shows us the metrics just for testing. So these metrics are going to be much bigger. You can see the trend doesn't look different, but the volume of defects is bigger because they're the ones that are found in testing, and typically people will find more in testing than operation. So here we can see, given the inputs that I have, we're only expected to fix 5% of the defects. So let's change a few inputs and see what happens there. Oh, now we're up to 11. Let's see. Okay, well, we can play around with that. There just so happens we have quite a few defects predicted to be found in testing. All right, so the sensitivity tab is next. Let's go there. Okay, the advanced sensitivity module is discussed in another video. It covers the 3 buttons you see there. The basic software has one capability for sensitivity. It will go through all of your questions that you've answered, and it will identify the categories where you had too many affirmative responses, meaning compared to the others. For example, putting all of your money into code reviews and not testing. That would come up here. You'd have too many yes answers in code, not enough yes answers in testing. That would be an example of what we could see here. In this particular case, I didn't have any real imbalances, so it's showing none. This will basically show where you have things unbalanced. Okay, the last feature in the prediction is the predicted versus actual. Requs AI predicts all of these metrics before the code's even finished. Once the code's finished and you've got test data, you can actually contrast your testing data, even your operational data, against the prediction. So let's go ahead and do an example. I have a file that has some test data, and I'm going to compare it against my predictions. And we can see there, the blue line is the prediction from Requs AI Predict. The black line is the actual fault intensity from the data. And the red line was a model from a third-party tool that was tracking this data. We actually have a reliability growth model that's in a different model of the software, which we cover in a different video, but that red line would come from an actual trending tool. So the red line is basically trending the actual data, where the blue line is purely predictive. All right, thank you very much.